Welcome back. So today we'll talk about the term outlier. Okay. So as it is written here, outliers are the extreme points which are not acceptable as the possible outcome of the observation setup. So when we talk about outliers, they are directly dependent on the choice that we are having to select the observation setup. Okay, so likewise, like here we are having the example of age of human being and age of working class. So if we consider the age of human beings, we would be interested to find out the ages in this range of 1 year to 120 years. And if we are getting any value that is not under this range, we can consider that value is an outlier with respect to the observation setup that we have taken. The next example is here. We are again discussing about the age only, but here the observation setup is the age of working class. So age of working class, for example, for my observation setup, I have taken in between from 16 years to 65 years. So any value that will be below 16 years or beyond 65 years, it will be termed as an outlier. Okay, so they are two different observation setups that we are having. So always remember that these extreme points, they are subject to the observation setup. Okay, so I hope that outliers is clear. Now there are two terms that are very analogous to the outliers itself. One is noise and another is anomaly. So when we talk about noise, it is generally related to the modeling itself. So let's suppose that I am having some data that is spread over this 2D dimension plane, and if I am building some model over there, then you will see that some points are there that are not basically mapped by the model itself very accurately. So these points can be termed as noise, and they add a lot of generality or general information to the model itself. So if I am having some different model, let's say I am having some overfitted model here, then we can say that only this point and this point are contributing towards noise. Okay, so the idea of outliers and the noise are differed by this concept of model. So outliers need the observation setup, but noise needs to be defined with respect to the model that we have chosen. Now, when we talk about anomaly, anomalies are the points that are generated by some different process. So let's suppose that I have taken a plot here, and let's suppose that I am plotting the speed of vehicle versus the duration of time. So I am having speed of vehicle on my x-axis, and I am having the duration on my y-axis. I am having duration for which the engine, a particular engine, has been turned on. So let's suppose I am having these axes here. So we can have data which will show that as the duration of the engine is increasing, the speed is also increasing, like this. And let's suppose that this data, when I was collecting this data, some data points got mixed with the data points of another experiment, that is the duration to which the engine has been on and the level of fuel. So you can see that as the duration will go up, the level of fuel will go down. So it will be having this sort of relationship. So let's suppose some of these points got mixed with this data set, these data points. So we'll be having something some points that would be distributed like this, and these points will be making an anomalous pattern on our data. Okay, so these points will be making an anomalous pattern, and these points individually will be termed as anomaly. Okay, so I hope the difference between anomaly, noise and outlier is clear. So anomaly is a data point that is generated by some different process, and an outlier is the data that has been generated by the same process, but it is beyond the range that is decided in the observation setup itself. Okay, so in the next video we'll talk about what are different methods by which we can detect the outliers and how we can remove them.